Good morning, sir.
Good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Morning, sir.
Good morning. Good morning. What was the last thing we covered in the previous class?
Sir, spring.
Strings.
The springs.
Since there is one more problem left over, I'll have to complete the problem. Have you completed assignment 3?
Yes, sir. Completed.
Yes.
Yes.
A bit.
Okay. One more problem on springs. This is a 2 kg block. This is a 5 kg block. You applied a force of 10 Newton on this and you applied a force of 20 Newton. If this is A and this is B, acceleration of A is 20 meters per second square towards left. Find the acceleration of B at that instant. Find the acceleration of B at this instant. Will you try?
Yes.
if acceleration of A is 20 meter per second square
Yes,
towards left, should I wait?
No, sir.
Done.
No, sir, you can start.
This is 10 Newton and it has 2 meter per second square of an acceleration, 20 meter per second square of an acceleration. So net force F net is equal to 2 into 20. This is 40 meter per second square. So how much is F net?
Newton.
So 40 Newton.
40 Newton. And you have only 10 Newton. So the balance force of
30 Newton.
should
Yes,
be
sir.
Kx should be 30
30.
Newton. You
Yes.
have only 10 Newton towards the left and it has an acceleration of 20 meter per second square. So net force you require to the left is 40 Newton. That means spring is compressed and not elongated. That means the spring is compressed. Compressed spring alone will be pushing this to the left. Compressed spring will be pushing this to the right. So acceleration of the 5 kg block will be 20 plus kx divided by 5.
Yes.
20 plus 30 divided by 5, 10 meter per second square. Here the silliest thing that anybody will have to recognize this spring is in the compressed state and not elongated state.
Sir, how you got the
You
kx?
know that it is compressed state. You have a force of 10 Newton and an acceleration of 20. That means you should have additional force in this direction. Only a
Yes.
compressed spring will push it to the left. Elongated
Yes,
spring
sir.
will push it to the right.
Yes.
Not give me 20 meter per second square of an acceleration. So instead of telling you people directly that the spring is compressed, they gave you the information that it has an acceleration of 20 meter per second square to the left.
Yes.
Small, cheap trick played, but well.
Sir, how you got the kx at 30 Newton is 40 minus 10.
Wonderful.
Sir, if
40 minus 10.
sir, if we don't know the spring is compressed and we take kx opposite, we get minus 30. And then
Yes.
we get, yes, sir,
By
AB 10.
default, we know that 30 is acting in this direction.
But then, sir,
Yes,
if
sir.
we do not know that the spring is compressed, then we can make mistake in finding the acceleration of B if we take force in the opposite direction.
Once you get minus 30, you will have to question your
Yes.
direction, right?
Yeah.
Minus 30 tells you that it is compressed. So you cannot take it as that way. You will have to take 30 towards the right.
Yes.
Sir, I didn't understand why the compressed spring is actually adding up to the acceleration of B. Compressed spring constant.
Compressed spring, you release it, how will it move?
Sir, it will elongate in all directions.
Right? So it is pushing that block outwards.
Okay, sir.
Tell me when I can rub the board.
Sir,
Dancer.
I am applying 100 Newton of a force here. Tell me the accelerations of the 5 kg block and the 10 kg block. Then I will apply 300 Newton of a force. Then tell me the accelerations of both the blocks. When I apply 100 Newton, what is the acceleration of both the blocks? 300 Newton, what is the acceleration of both the blocks? 500 Newton, what is the acceleration of both the blocks?
Sir, is the upward force 100 Newton or 3?
First I applied 100 Newton,
We
tell
did
me
three
the
cases,
acceleration
no?
of both. Then I apply 300 Newton, tell me the acceleration of both. Then I apply 500 Newton, tell me the acceleration of both.
Sir, the string on the left side, it's kept idle, right? It's not attached to anything.
Yeah, I get fixed it to the base.
Sir, is the platform fixed?
Platform is fixed. Here acceleration of one of the block is not given for you people to apply constraints.
Yes, sir.
Acceleration of none of the blocks are given. So you'll have to start with dynamic equation. Always remember one thing. If acceleration of one of the block is given and the other is asked, that means they are hitting on constraint. Acceleration of none of the blocks are given, you'll have to start with dynamic equation.
So do we answer on chat?
Yeah, I'm seeing the answers. In the first case, when you are applying 100 Newton, what will be the tension here?
50,
50, sir.
50 Newton,
Right? What will be the tension here?
25 Newton.
25.
5.
25 Newton. What is the weight of this?
5
Newton.
Both will not.
Both will
100
not.
Newton. On a 50 Newton block, I apply 25 Newton force. Will the block move upwards?
No.
No, sir, down.
Sir,
The acceleration of this will be zero.
Zero.
Don't tell me downwards. There is
Yes,
four
sir.
normal forces balancing it.
Yes.
Acceleration of
15 meter per second.
0.
I have dealt with for the first case. Please deal with the second and the third.
Done, sir.
In the second case, when
Sir,
300
zero, sir. Both will be zero.
applied, pardon?
Sir,
So
both
wait,
the accelerations will be zero in second.
This will be 150,
150.
will
Yes,
be
sir.
150,
75.
75.
25.
75 and 75. 10 kg block, will it rise up?
Zero.
No.
zero,
Zero.
Acceleration of this will be
5.
5 meter per
75
second.
Yes, sir.
by
Yes.
5.
yes, sir.
25 by 5, this is 5 meter per second square. This acceleration is 0.
Yes, sir.
Now you know what is to be done for the 500 Newton. I am waiting.
Yes,
Please
sir.
make it fast.
Yes, sir.
That
Done.
also does. Yes, sir.
Sir,
Easy.
that
Put
also
on
done.
chat.
Yes,
Done,
sir.
sir.
Okay. Okay.
Sir, one such question was there in assignment 2.
Assignment 2 means there is a small difference there. Left side block,
Was accelerating upwards.
there's a small difference, but something close to this. Now, see what they have done to this problem. They are applying a force of 20T. Calculus is coming into picture. You are making the force a function of time. Right? This is the 1 kg block. This is a 2 kg block. There is a good catch in this problem. Time t is in seconds. T is time in seconds. They are asking you find the velocity of the 1 kg block. Find velocity of 1 kg block when 2 kg leaves the surface. When the 2 kg block leaves the surface, you are interested to know the velocity of the 1 kg block. Firstly, did you understand the question?
Yes, sir.
Can you tell me at what time will the 1 kg block leave contact with the surface?
1 second.
As soon as the force is applied.
Yes, sir. 1 second.
Yes, sir. 1 second.
10T, 10T, 10. Now this will be 10 Newton in the downward direction, 20 Newton in the downward direction. When do you think 1 kg block will leave contact?
10 T is
10 T
equal
equal to 10. T is equal to 1
1
second.
second. So at 1 second, 1 kg block will leave contact. When will the 2 kg block leave contact?
2
seconds.
2 seconds.
So the question asked is between 1 second and 2 seconds, what is the velocity acquired by this particular block? Is the question clear?
Yes, sir.
Will you try?
Yes, sir.
I'm waiting for it.
Find velocity of 1 kg block, then
2 kg leaves the surface.
no, sir, in between block.
When?
Question, right?
Sir, can you once repeat what we have to find?
Can you read this line? That's what you have to find.
Sir, so we have to find the velocity of 1 kg block at 2 seconds.
Please read this line loud. I want to listen.
Find velocity of 1 kg block when 2 kg leaves the surface.
That's it. Why do you want me to give me the interpretation for that statement? That becomes a hint.
Done, sir.
So 1 minute.
Sir, 1 minute.
Your dynamic equation for this will be 10t minus 10
minus
is
10
mass
equal
into
to mass into
acceleration.
acceleration.
Yes,
Vector
sir.
sum of all the forces is mass into acceleration. Agreed?
Yes.
Yes, sir.
10t minus 10 divided by mass divided by 1 into dt is dv. Integral dv is 10t dt minus 10 dt.
Yes, sir.
Tell me what are the limits for the time?
So
1
1
to 2.
1 to 2.
1 to 2.
0 to e.
Now, why didn't you take 0 to 2 seconds?
Because 0 to
1
1
पे
is
तो
0 पे
उठा
तो
है
1 ही
ना।
मूव नहीं कर रहा था ना.
Yeah.
the ground, not at the starting.
0 to 1 second, this dynamic equation will be wrong because there is one more force acting on it, normal.
Normal reaction.
Yes, sir.
Till 1 second, 1 kg block is on the ground. There is another force called normal force. Your dynamic equation will be wrong if you take 0 to or 2 seconds. Students argue 0 to 1, either way the block was at rest. 1 kg block was at rest at
Yes.
0 second, 0.5 seconds, 0.7 seconds, or 1 second. But agreed, your limits may be right. At 0 also velocity may be 0, but your dynamic equation will be wrong.
Okay.
0 to 1, there is another force called a normal force
Normal.
acting on the 1 kg block. Is this point clear?
Yes, sir.
Yes.
Sir.
Make it fast.
So final answer is 65, right?
Yeah.
So velocity.
ऐड भी कर देंगे दोनों तरफ तो भी 65 नहीं होगा.
65.
5 तो नहीं है।
5 होगा ना. हाँ 5
5
होगा.
होगा ना,
5
होगा.
5 आ रहा है मेरा तो।
5.
65 तो आते आते शायद दोनों ब्लॉक्स पुली को भी हिट कर देंगे.
Yes sir, 5 ही आ रहा है।
हाँ सर 5.
Ah, sir, sorry, made a mistake. Took it as 4 square.
Simplification mistakes are the costliest mistakes in an examination. बाहर आकर बहुत पछताओगे अगर ऐसा simplification mistake किया. Question पता है आपको, concept पता है, solution पता है, and you put simplification mistakes. Way back 2008, if I'm right, we had an All India ranker 14th rank. That year we had 2 students in the top 100. The 14th rank student, he committed only one mistake. 18 by 9 he marked as 9, integer.
Oh,
18 by 9, this is a common mistake which we tend to commit sometimes. 18 by
Yes.
9, in a hurry under pressure, he marked it as 9. And those days, integer type question was 7 marks. Can you believe that?
7 marks.
Oh,
7 marks, you go
Negative?
wrong, you get -2.
Sir,
I
he
mark-
was in the
And
9 marks.
yet he was All India 14th rank.
गलत नहीं हुआ रहता तो सर मतलब
So the first
एक
rank.
बहुत
First
डिस्टेंस से
rank.
फर्स्ट होता.
टॉप 5 में रैंक आ गया होता अगर वो एक क्वेश्चन सही किया होगा. And it is human pressure. You cannot tell that you shouldn't have committed this mistake. 2-3 hours is very difficult to concentrate.
Yes, sir.
Yes, sir.
सर बट 14th और 5th को मतलब सेम ही कॉलेज मिलेगा ना, टॉप मोस्ट कॉलेज में टॉप मोस्ट सब्जेक्ट.
So rank.
For them it matters not because 14th ranker or 10th ranker both will take computer science in IIT Bombay.
Yes, sir.
यस
Computer science. But for the institute getting a rank in the top 10 again it takes years. Somebody is carefully observing the national ranking given for different institutes.
yes,
One of the
sir,
student
yeah.
writes IIT Madras is ranked 1 by NIRF.
Yes, sir.
Yes.
For your information, last 3 years say NIRF is
Yes.
giving IIT Madras
Yes, sir.
first rank, not
Yes,
this year.
sir.
Google search last year and the previous years as well.
Second is
Yes,
IIT.
since last 3-4 years. IIT Bombay is third.
IISc, right?
Bombay presently is in third. Last year it was in second position.
Second, sir. Yes, sir.
सर फिर भी लोग आईआईटी बॉम्बे प्रेफर करते हैं.
Sir, NIT
हाँ,
Trichy has
sir.
gone down now. Sir,
Trichy
NIT,
and Surathkal are doing very well for your information. NIT, Trichy and Surathkal, they are good institutes.
sir, Karnataka also.
Surathkal is Karnataka only.
Surathkal is
Oh,
Karnataka.
sorry, sir. Sorry, sir.
Tomorrow you tell me Mumbai and Maharashtra.
No, sir. No.
Theta is constant. Bachpan mein we used to be asked a question. A man goes around a park in 120 minutes
Yes, sir.
with the
Yes.
same speed,
Yes, sir.
right?
2.5 घंटा.
Suppose he is going in the reverse direction, he will take 2 hours.
Yes, sir.
Why?
Because
Sir, you had told this.
Right. वो अभी सूरतकल और कर्नाटका बोल रहे हो तो मुझे उसकी याद आए. B is a positive constant. B is a positive constant. Theta is constant. M is the mass. Right? T is the time in seconds. T is the time in seconds. A standard error problem. The way calculus comes into, you can make out. Question asked is after some time, M leaves contact with the horizontal surface. Find the velocity at that instant. When M leaves contact, find velocity at that instant. Will you or should I?
Sir, we'll
We
try.
will, we will.
First, find out the time at which the body loses contact. At what time will the body lose contact? First, find out that. That will give you the limits.
Done, sir.
No, sir.
Yes, sir. हो गया.
Very good.
Done, sir.
This will be the normal force plus BP sine theta. This will be BP cos.
Cos theta.
Yes,
Yes.
sir.
When will the body lose contact? When normal force becomes zero.
Yes, sir.
Yes.
Sin theta is equal to mg. When normal force
dt
becomes
sin
zero,
theta becomes.
sin t naught will
Yes, sir.
be mg by b sin theta. This is the
Yes.
time at which the normal force becomes zero.
Yes, sir.
Why are you so keen on the normal force becoming zero? It is that instance at
Leaving
which
contact.
small m leaves contact with the ground.
Yes, sir.
Now, you are asking me what is the velocity acquired. Acceleration is dv by dt in the horizontal direction. Bt cos theta divided by m.
M.
Yes,
Cos
sir.
divided
Yes,
by
sir.
mass. Right? dv is equal to b by m cos theta dt. Time t equal to 0, velocity was 0, which I should have told in the question. By default, you people assumed it, but that should be told in the question.
Yes, sir.
T naught, find out the velocity. T naught value is this. Should
तो
not
cos
be
theta भी
difficult.
बाहर आ
The
जाएगा ना,
cos
theta
theta will
constant.
come
Cos
out and
theta
there'll
is
be
a
Yes, sir.
constant, bring it out. Cos theta is a constant, bring it out. Integral dt will not be difficult for you.
So
to
integral
integrate.
t dt, right?
Yes, sir.
The
T.
integral t dt.
I forgot this t.
Cos theta will come out and integral t dt.
T. This is b cos theta.
So
Take it down. I'll just be back in a second. Cos theta, bring it out and keep t inside. Integral t dt.
Sir, what about the velocity in the vertical direction?
That will be zero.
It has just left contact,
Take
na,
off from
so-
the ground. How will I have
Okay.
velocity till t naught? Till t naught,
Yes, sir.
the body didn't take off from the ground.
So can you please explain why normal reaction is zero?
It loses contact with the ground means normal force should become zero. That is the criteria for two bodies to be in contact. If two bodies are in contact, there is normal force. If they lost contact, normal force should become zero.
Thank you, sir.
Sir, what is the answer?
Integral t
Sir,
dt.
b by m cos theta t naught
mg
squared
squared
upon
upon 2b cot theta cosecant theta.
Yes, sir. Mg square by 2b.
Done, sir.
Yes, sir. Done.
We extend this question one step ahead. We ask what is the horizontal distance covered before it loses contact with the ground. Find the distance covered in time T naught equal to how much was T naught?
mg upon b sin theta.
Yes, sir.
Mg upon b sin theta. Now, if you're asking me for the distance covered, technically I should find an expression for velocity as a function of time.
Yes, sir.
Small adjustment here. Don't substitute the limit t naught. Keep it as
Yes,
a
sir.
function of t. Don't substitute the velocity as t naught. B cos theta by m. That will be t square by 2. 0 to t square by 2.
Yes.
Now v I will write as ds by dt. B cos theta by 2m t square, and bring dt to the right and
Yes, sir.
integrate. You will get the distance. T square dt. 0 to t naught, 0 to s. Should not be difficult from here.
Yes, sir.
But they haven't said horizontal distance.
All that we have to do is just make sure don't substitute the value of t naught here, so that you'll get velocity as a function of time. Only then I can integrate that. I get a constant value integration does not make sense there, right? Find velocity as a function of time, then write velocity as ds by dt, take dt to the right and integrate.
Sir, sir, can you please explain once again why didn't we take a vertical component of that force? Why didn't we differentiate? Why didn't we consider it?
Your question is why didn't we?
Yes, sir.
Vertical component of the force, when it is moving horizontally till t naught, it is not leaving contact with the surface. Till this time t naught, it is not leaving contact with the surface. It is on the surface. So its vertical
Okay.
displacement is 0.
Okay, sir. Okay, sir. Got it.
Somebody is asking, can we leave the answer in terms of cos theta? Cos theta is given to you. You will have to report in terms of cos theta only.
Sir, in this also we have to last put the T naught value. After
Yes.
the-
Yes.
Your last step, you will substitute t naught value.
So what will be the final answer?
Cot
Somebody-
theta cos x square theta m square g cube by 6b square.
Sir, wait. Done, sir.
Now, suppose you give me a rope and you are pulling with a force of F. Rope of mass M, rope of mass M, and length L. It's kept on a horizontal floor and you are pulling with a force of F. Smooth horizontal floor. Till now for you the rope was massless, so the tension was the same all throughout. You are pulling with a force of F, the string will have a tension of F.
Yes, sir.
Agreed?
Yes.
Now, because the rope has got some mass, there will be tension which will be varying along the length. There are two ways of finding out the tension as a function of length. 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 One way of doing it is, suppose I want it at a distance of x. Split the material at a distance of x and connect this with a string of negligible mass. split the material at a distance of x. Split the material at a distance of x and connect a string of negligible mass. Haven't you changed the problem? We didn't change the problem. This is a string of negligible mass,
Yes.
right? So then what happens? All of this system will have an acceleration of F by m, right? This is the only external force.
Yes, sir.
So you will have a tension T here. So you can write the equation as F minus T is mass per unit length into x. I'll get the mass of this. This into A.
Yes, sir.
Yes,
F
sir.
minus T is mass of this into A. And for this, mass per unit length into L minus x into A. This tension will be mass per unit length into L minus x,
Yes.
right? Once I know the acceleration as F by m, substitute, you will get the tension here. Mass per unit length into L minus x into F by m. M and M will get cancelled. Force per unit length into L minus x will be the tension at this particular point. This is one way of doing the calculation, which is not the orthodox way of doing it. Only when the acceleration is linear, you will get the answer using this procedure. Cutting this rope at this point, placing a string of negligible mass, finding out the tension in that string will give you the answer only when the mass is having linear acceleration. Not the orthodox way of solving this. But what will be the orthodox way of solving it? Visualize this carefully. Tension, you told me, is always pulling. It acts away from a point with respect to the point. Tension always pulls. Suppose I consider a rope like this and I'm pulling with a force of it. Consider an element dx at a distance of x.
Yes.
Now this element dx will be pulled to the right and to the left. It always tends to stretch. Tension will always stretch the body.
Yes.
This will be T plus dt, this will be T on the small element dx.
Yes.
What makes you say the force on the right side will be greater? Because the system is accelerating in that direction.
Yes, sir.
Now dt I can write as mass per unit length into dx. Into, this is the mass.
Yes.
Into acceleration is F by m.
Yes.
dt is mass per unit length into dx. Unitary method.
Yes, sir.
Yes, sir. Yes.
Into acceleration. What is acceleration? F by m.
Yes, sir.
Integral dt. Very technically, I will put a negative sign in front of it. क्यों भाई साहब नेगेटिव साइन क्यों डालोगे? dt by dx is negative. dt by dx is negative. Why is dt by dx negative? Tension is decreasing as x is increasing.
Okay, yes, sir.
Tension is decreasing as x is increasing. As you are moving to the left, tension at the extreme end is 0.
Yes, sir.
Tension is decreasing as x is increasing. Right? So dt by dx is negative. So don't forget the negative sign. Now I can take limits in two possible ways. At x equal to 0, the tension will be F, the force you apply. At
Yes.
x equal to x, I want tension as a function of x. So this will be t as a function of x minus f is minus f by L into x. Integral dx is x minus 0. Tension will be F minus Fx by L. F into L minus x by L. Is this the answer that you were expecting?
Yes, sir.
Yes.
Here, listen all of you.
Yes.
Just out of academic interest, if somebody says, I don't want to find the limits at x equal to 0, at x equal to L, I know tension is 0. You have told me the reason for taking negative sign is tension is decreasing as I'm moving. So at x
Yes,
equal to L, at x equal to L, tension is 0. Do you want me to substitute that? You can. You will get the same answer. I'm running short of space on the board, so I will not do it that way. But suppose I take it x equal to L, tension will be 0 here.
Yes.
And if x equal to x, I want the tension T. Substitute and see, you will get the same answer. Right? At x equal to L, at x equal to L, what is the tension? 0.
0.
At x equal to x, find out the tension T. Substitute, you will get the same answer. So whole of the game in this is either this or this procedure. If you know the acceleration, the job is done. In your assignment, you have two problems. One, the rope is made to accelerate on an inclined plane. Two, horizontal. जहां भी चाहिए आपको, cut the string, cut the rope, place a string of negligible mass, find out the tension in it. That's your answer.
Yes.
Yes, sir.
Sir, can you tell how you got the value of dt in the right side?
dt is mass per unit length into length of the element. Mass per unit length into length of the element. That gives me dm. Into acceleration. Acceleration is f by m.
So the capital T that you've written acting on dx will be equal to F.
One second.
In the assignment sheet, there was a question on one of this topic.
Two questions are there on this.
Yes, sir. Question number 2 itself is the same. Sir, why you are not there in the doubt, sir? Last time in Thursday, no, you are not there. This was someone else was there. Physics doubt.
टाइम टेबल जब एडजस्ट नहीं होता है, they'll adjust it that way.
Sir, is dt equal to force that is being applied?
Pardon?
Is dt equal to the force that is being applied?
3t equal to 4 seconds.
Sir, is dt equals to the force that is being applied?
dt equal to mass into acceleration. dt is the net unbalanced force on dm. This minus this.
Okay,
This
sir.
minus this is the net unbalanced. That is equal to mass into acceleration.
Okay, sir.
Sir, but how did you get that on the right t plus dt and on left t in the
Unless
FBD?
this tension is greater than this by a small element, this element will not accelerate in that direction.
Okay. Okay.
So technically you will take T1 and T2.
Done, sir.
Sir, we assume that the mass is uniformly distributed across the route, right?
Pardon?
So we assume that mass is uniformly distributed across the route.
Naturally. If not, this will not work out. Mass per unit length into length will work only if
It is uniformly
Mass
distributed.
is
Otherwise, we'll need
uniformly
mass
They'll
also the
give you
function
the
of
function. They'll give
mass
you
is
the
a function of length. Sir.
That function into x will give me the mass in that particular area.
Okay, sir.
Can I rub the board?
Sir, 2 minutes, sir, bas.
Sir, 1 minute. Sir. Sir, when will you take the doubts from assignment 3?
Right now.
Okay, sir.
This completes Newton's laws, not friction. Not
Yes, sir.
friction. This completes Newton's laws. Homework.
Sir, full booklet?
Let.
अरे नहीं, booklet में friction and Newton's laws are merged.
Oh.
Right?
Sir.
Homework. Complete HCV.
So full? Okay, sir. Done.
Okay, sir.
HCV has split the chapter Newton's laws and friction
Yes,
separately.
sir.
Yes, sir. Yes, sir.
So complete HCV.
Yes, sir.
And I think you people finished assignment 3.
Yes.
Yes,
Sir.
Yes,
Sir,
sir.
doubt-
Sir, if it is
sir.
not finished, then what should we do?
Finish it.
Sir, only
और क्या कर सकते हैं भाई?
No, sir, what this doubt? This
This is also
doubt, rest of the
unreasonable.
lecture,
If
this
I'm not
doubts,
finished
right?
the assignment, what should we do? Obviously finish it.
No, sir, rest of the lecture is doubts, right? That's why. About regarding this assignment.
डिस्कनेक्ट करके
sir, the
सॉल्व कर लो,
questions
जो
which
डाउट
are-
आएगा वो रिकॉर्डिंग देख लेना.
Yeah, that will also do. People
Okay,
have
sir.
not completed the assignment. How many of you didn't complete the assignment or need additional time? Raise your hands.
सर डाउट वाले क्वेश्चन रीअटेम्प्ट करना बाकी है सर.
जो भी है, tell me the numbers. If you are in the majority, I'll postpone the discussion of the doubts.
Sir, there were 30 questions. You can do only first 20 or something like that for others.
Yes, sir. वैसे भी कर सकते हैं.
30 questions में first 15 discuss कर लो.
हाँ, sir.
Yes, sir.
Yes, sir.
सर स्पैमर है मीटिंग.
ये आइडिया स्पैमर का है।
सर कोई तो है स्पैमर सर, BTS।
BTS they left, I think. Yeah, they left.
सर छोड़ दो।
जिंदगी में कुछ लोगों के पास इतना टाइम है।
सर वो
हाँ सर वही।
यस
भाई
सर
सर मुझे तो समझ में नहीं
I
आता इतना
feel
टाइम मिल
jealous,
रहा कहाँ
sir.
रनिंग शॉट थोड़ा टाइम मिल जाएगा तो वी आर रनिंग शॉर्ट ऑफ सर्चिंग टाइम फॉर आवरसेल्व्स these
यस
people
सर
have
टाइम मिल जाएगा
थोड़ा
वही
थोड़ा
तो
उधार
होमवर्क एक्स्ट्रा नोट सब बना सकते।
सर फोटो असाइनमेंट के भी एक दो बाकी है।
यस
So
सर।
one doubt.
फर्स्ट वन।
Sir, third question.
assignment 3 doubts in the first 15 बोलो first
Third
one
question.
Question
फर्स्ट
Sir,
थर्ड
question 10.
Question one.
क्वेश्चन 1 क्वेश्चन 3
3.
Sir, question 10.
सर 11
14.
ऑल क्वेश्चन। यस सर क्वेश्चन 10
सर
So
3।
are you going to only doubts right now?
yeah I'll take up only doubts
सर 13
यस सर 30
Question 4.
6, 7.
सारे
सर पूरे एक्सरसाइज लिख दो सर।
सर 8. तो 3 नहीं बच्चे।
सर 5
रुको असाइनमेंट तो खोलने दो मुझे
सर ये वाला थोड़ा कंपैरेटिवली इजी था।
हाँ दिख रहा है,
था इतने सारे
दिख रहा है।
जिसने भी 8 पूछा ना उसका नाम पकड़ो ना सर प्लीज।
सर 8
जिसने भी
वाले का
8
नाम
पूछा आपसे
सर ऐसा बोला ना
8
कि
वाला
मतलब जो
किसको
डाउट पूछ
कैसे
रहा है
डाउट आ सकता है?
सर जिसको जो क्वेश्चन में
और
डाउट
सर
है अपना
6
नाम
वाला
बोले।
भी डिस्कस किया हुआ HCV में।
हाँ सर
सर
नेम
हाँ सर
लेके
मतलब
पूछो।
डाउट
वो 6
पूछते
वाला
समय नाम बताना पड़ेगा।
Sir, discuss कर चुके हैं.
question is also unreasonable doubt B is moving towards right with an acceleration of 8 find the mass of A अब देखो (37°) 3 kg this is moving with 8 meter per second square
Yes sir.
right so what will this be moving with if I call this to be V naught in this direction this is 37°. Right? This angle is 37, this angle is 53 degree. V naught cos 37 will be equal to 8 cos
8 cos 53.
Equate both of them. I should get, sorry, acceleration. This is V naught. Because this is 8 meter per second square, right?
Yes.
Yes sir.
Keep an eye on the units that will tell you what quantity they have given. So technically I will get A naught as 8 cos 53 divided by cos 37. Will somebody tell me how much is A naught?
6 meter.
6 meter per second square.
Yes.
It's more like I have given you the answer and I'm asking you for the equations. 37°, right? Now see the free body diagram. This will be mg. What is that? Ma into g. This will be the normal force. Its vertical component will be
n cos theta.
37. This is n cos 37. Horizontal क्यों नहीं ले रहे हो यार आप? Least interested in the
मोशन
horizontal.
नहीं है सर हॉरिजॉन्टल वुड मेक अ डिफरेंस।
Ma into g minus n cos 37 is
ma into 6.
MA into AA.
A you calculate. Reaction of this normal force is n. This will be n sine 37 is equal to mass of this is 3 into 8. Can there be better two equations to simplify?
नो सर
No.
Very, very, very easy question. Now you can solve the second question based on what I have explained today. Cut the rope there, place a string of negligible mass and write the dynamic equation straight hit. You will get the answer.
यस
Yes, sir.
सर इसके बाद और एक असाइनमेंट है क्या?
What?
The next assignment will be combined with friction.
ओके सर.
So friction is tough.
Friction is tricky, not tough. It is tricky. Third one, drawing the diagram is bit lengthier. It's okay. You are
To
putting
redraw the
this
diagram
velocity of you, right?
Yes, sir.
Keep an eye on the diagram. If I go wrong, there are multiple pulleys here which we should be careful with.
Yes, sir, now.
You did a good job, right? Drawing the diagram.
Yes.
Yes,
You
sir.
even drew
Yes,
it very
sir.
fast.
I tried Yes, 4 sir, times, it's couldn't me. make it.
This will also move to the left with a velocity of v. This pulley should not be hanging. That's a mistake. This pulley is also not hanging. What else do you need? Let me start from here. Principle of virtual work.
Yes, sir. Can you use
Yes, sir.
Yes, sir. Can we use that,
This
sir?
will be T. This will be T. This will be
वही
2T.
सर, अब वो नीचे वो फिक्स चीज तक टी रहेगा, वो एक ही स्ट्रिंग है, लेफ्ट तक वैसे जाएगा.
Yes, sir. The
Okay.
same
This
string.
will be T. This will be T. This will be T. This
Yes.
will be T. This will be 2T. What
Yes.
will be the tension here in the vertical direction?
T.
T.
T. T.
T.
Yes.
Now this will be T. This will be 2T. This will be 2T. What else do you need?
Sir, इससे नहीं आता आंसर. मैंने
आता
try
है भाई, आता है, आता है.
नहीं आता भाई.
इतना कॉन्फिडेंटली वो बोल रहा है, देखो आंसर नहीं आता है, इसको हैंग हिम अपसाइड डाउन. 2T into U are in opposite direction. Shall I put a negative sign or positive sign?
Negative sign.
Minus T into U. Now here 2 plus 1.
3.
4.
6.
6T into, call this V0, should be equal to 0.
Yes.
So I didn't miss anything. This will be minus 3U is 6 V0. किसका velocity पूछ रहा है?
V naught का U by 2. Yes, sir.
Yes.
किसने बोला आंसर नहीं आ रहा है?
Naveen.
Upside down for 5 minutes. Take the video and send it to me by email.
Okay.
Sir, there will be no tension between the two down pulleys.
They will cancel out.
Spring. Yes.
Even if it is, let me assume they both are unbalanced. Even if they are not
Horizontal direction.
thinking only about vertical direction.
Yes, sir.
Okay.
Then they will cancel out.
Here, luckily, both are equal. Problem for the sake of problem. इतने सारे पुलिस कौन हैं? For you, the job is done in 2 steps. But when you see such type of problems for the first time, it will appear to be frightening. But actually,
Yes.
there will be.
Yes.
Yes, sir.
I drew this diagram 4 times, sir, because I was getting the wrong answer.
Sir, एक भी बार draw नहीं किया.
Sir,
assignment
बिना
में edit
diagram
करके.
बनाए
हाँ, sir,
Yes, sir,
exactly.
we highlighted it on the assignment और हो गया.
वो string constraint से कर लिया.
हाँ सर, उससे भी हो जाता है easily.
The virtual work will be shorter here, but
दो स्टेप्स में आंसर आ गया. Now, fourth question. Did I draw the diagram correct?
Yes, sir.
Theta. This is A. This is B. This has an acceleration of A. Right? What did he ask? Find the acceleration of block B at this instant. Acceleration of block B. This will be AX. This will be AY.
Yes, sir.
Yes.
Yes.
Acceleration of block B, AX and AY. A is given.
Yes.
So AY will be how much? A sin
A sin theta. Yes.
A sin theta. Do you remember this constraint I had to
हाँ
look?
sir.
Yes,
हाँ.
yes, sir.
Yes.
Yes,
AY.
sir.
I get that. Now relation between AX and A अगर आ गया तो आंसर आ जाएगा. अगर look at it, this is moving to the left by x naught. This by x naught. This by x naught.
Sir, 2x now.
This wedge is going toward the left by x naught.
Okay.
This is going down by x. Segment 1, segment 2, segment 3, segment 4, segment 5. You might have applied principle of virtual work. For a change, I am applying regular constraints. Or do you want me to do it using principle of virtual work?
Sir, virtual work.
Sir, regular
constraint
constraints.
You have
Virtual
another
work we
method.
got.
Regular constraint
Yes,
करेंगे
got
एक
it.
बार ताकि you will also be confident. Segment 1 में, if I am solving with respect to ground, this will be x naught cos
Cos
theta.
theta.
Yes.
Segment 1 में both endpoints are moving away. X naught cos theta plus x. This will be minus x naught. This will be, if this is moving by x naught, this is moving by x naught, this is x naught, x naught. Segment 3, this is segment 2, right?
Yes, sir.
Segment 3 is minus x naught. Segment 4 is minus x naught. Segment 5 is minus x naught. Sum total should be 0. X is equal to 4x naught minus x naught cos theta. Ax
Minus
is
x
equal
naught cos
to
theta.
4a minus a cos theta. Ax आ गया, ay आ गया. Resultant is root over of ax square plus ay square. Always remember one thing. जब एक body का acceleration is given, all you need to do is constraints to get the acceleration of the second body. You don't need the dynamic equation.
Yes.
And here all the more I will clearly know that I don't need the dynamic equation because masses are not given. Right? When masses
Yes.
are not given, how will you put the dynamic equation? It's only a game of constraint relations. Take this down, I'll just be back in a second. I'm keeping you people on mute. Can I rub the board?
Yes, sir.
Yes, sir.
Yes.
Six. An empty plastic box of mass m is found to accelerate up at the rate of g/6 when placed deep inside the water. Buoyancy mg.
Sir,
This
we
is
found a
that
very
g/6.
common problem in HCV.
So this was an
Yes, this
HCV.
was the HCV problem.
Yes, sir.
Indicated so that it must accelerate down at the rate of m plus m naught. जिसका भी ये doubt है, you didn't even attempt this. Minus buoyancy, it should be go down by g/6. Here the dynamic equation is buoyancy minus mg is m into g/6. Here m plus m naught g minus buoyancy is m plus m naught into g/6. Not a fair doubt. Seventh one, this angle is alpha, this angle is beta. This is m1, this is m2, m1 and m2 attached on the ends of a light string which passes over a massless pulley attached on the top of the double inclined surface, smooth plane of angle of inclination alpha and beta. Tension in the string is fair
The
enough,
direct shortcut.
right? T is 1 into g sine alpha plus 1 into g sine beta divided by 1 square by m1 plus 1 square by m2.
Yes, sir.
Yes, sir.
Sir, in the sixth one, I just want to confirm buoyancy force depends on volume, not on mass, right?
Right.
Okay.
Eight. Figure shows a uniform monkey of mass 20 kg climbing up the rope to balance the cage of 25 kg. What is the acceleration? The tension should be?
250
Tension should
Newton.
be 25 g. So
Yes,
as far as the monkey is concerned, this is t. Not a fair doubt here. What is the mass of the monkey? 20.
20.
20 g. T minus 20 g is 20 into a. How much should t be? 25 g.
25.
T should be 25 g for that to be balancing.
G by 4.
25 g minus 20 g is 20 a. You're asking me the acceleration of the monkey. Eighth question. Not fair. If this is the doubt, we have dealt with three monkeys. Of
Yes, sir.
Ille.
Question number 9 also the same problem that we have dealt today.
Yeah,
It's from HCV.
Split the rope at 10 centimeters from left. Place a string of negligible mass.
Yes, sir.
Get
सर
the
सेकंड
tension.
अप्रोच भी ट्राई कर सकते हैं ना?
Pardon?
सेकंड अप्रोच से भी होगा ना?
इंटीग्रेट क्यों करना है, आराम
Calculus
से हो
वाला,
जाएगा.
why?
ओके सर.
Think of an alternative method only if it is either very innovative or a shorter method. If not, not worth investing our energy on. Then कभी कभी ऐसा लगता है कि डाउट्स में आप लोग टाइम पास करते हो.
हाँ सर.
I don't find that seriousness in you people when you people technically ask doubts. हर silly question doubt पूछ लेते हो आप. This is T. T is the force applied. This is T. This is T. This is 2T. Now, platform moves upwards at a steady velocity. Now, see the platform's free body diagram अगर आप draw करोगे, this will be 2T, and the girl's normal force reaction will be here. Platform का weight कितना दिया हुआ है?
25
kg.
25 G. What is the weight of the girl? Girl's weight
50 g.
right? T plus normal force is 50 G. Here, students will commit only one mistake. They tend to take normal force to be 50 G,
Downwards,
which is a
yes.
mistake.
Yes.
Normal force plus tension. Girl is pulling the string with a force of F. The string will pull the girl with a force of F. That's the tension. Should be equal to 50 G is my first equation as far as the girl is concerned. Reaction of the normal force, right? 2T and mg. Now here it will be 2T will be equal to 25G plus normal force. This is the second equation. Two equations, two variables. T is, and moving with uniform velocity is a
Yes,
cap
sir.
there. Moving with steady velocity implies net force is 0.
Yes,
So
sir.
equated forces in upward direction to forces in downward direction for both the girl and the block.
Sir, I have a shorter method.
Hmm.
We treat the girl and the block as one system, and the mass of the system will be 75 kg, and tension acting will be
Absolutely right.
3.
You can do that because they didn't ask for the normal force between the girl and the block.
So we don't need to
They
calculate.
asked only T. So you don't need the normal force. I
Yes.
put both the equations because next stage, if ever they ask for normal force, you can calculate.
Yes.
In this case, they didn't ask for the normal force. Just deal with the external force, the job will be done.
Done, sir.
Now, 11th question.
Yes, sir.
All you have to draw is the free body diagram carefully. That's all.
Okay,
A
sir.
lot of normal forces and this
Yes,
is all
sir.
you need.
Now, radii, I don't know what 4 and 5 are given.
So that's used for the
Given.
angle. For the angle.
Yes.
Because one of them will act at the angle.
Yeah, you people deal with this and this, right? Now have a look at it. Here I will call this N1, right? I draw the normal force on this, normal force on this. This will be N2, N2. This will be N3,
Okay, sir.
right? Now, this will be N4. I wish I could do it. I draw it upwards, N4. Right? Here normal force is N2 and N2. Now can I resolve N2 in the horizontal direction? This will be equal to N1.
Yes, sir.
Vertical component of N2 will be balancing mg. Same applies here. N3 will be equal to the horizontal component of N2. Mg
Yes,
will
sir.
be balanced by N4 and the vertical component of N2. I'll call this N2y. I'll call this N2x. You people will resolve it. N2x, N2y. See if the free body diagram helps. To my knowledge, it will be surplus. On this block, N1
Yes, sir, that
is
is enough.
equal to N2x. On
Yes,
this
sir.
block, N2x is equal to N3.
Yes, sir.
Vertical forces N4 plus N2y will be equal to, sorry, N4 upwards, Mg plus N2y. Similarly, N2y will be equal to Mg.
So N1 is equal to N3, right?
Yes, sir.
Yes, sir. That's
Sir,
right.
what is the
N1
angle
will be
between them?
equal to N3 because these both are equal and opposite, N2x. It's just the free body diagram drawn properly. How did you resolve N2x and N2y, for which you should know theta, for which the radii are given?
Yes, sir.
No, sir, 2 minutes.
So done, got it.
Well, no, 12, 13. 13th, देख लो आप एक बार. This is force, this is time. I'll tell you the hint. ध्यान से सुनो. 7 Newton for 1.5 seconds. 7 Newton for 1.5 seconds. And then 5 Newton for 1.5 seconds. 5 Newton for 1.7 seconds. This is 5. Right? Then 10 Newton for 3 seconds. 10 Newton for, sorry, this is 1.7.
Plus 1.7. Yes, sir. 3.2.
3.2. Now from here 3 means 6.2 seconds. Am I right?
Yes.
sir.
Yes, sir.
Now, technically, what will give me the area underneath for this graph? F into delta
Change
T
in
is
momentum.
dt,
Hmm.
right? 0 to P, 0 to T. That means area underneath will give me delta P. Change in moment.
Yes.
Finding out the area under this, and area under this will not be difficult for any one of you because they are rectangles.
Yes.
So I will get delta P1, delta P2, delta P3. Net delta P is delta P1 plus delta P2 plus delta P3. This is the net change in momentum.
Divided by mass.
Yes, sir.
Change in velocity.
Sir, and initial velocity is 0.
Delta P whole square by 2m is change in kinetic energy. Why do I go into that? उसने velocity तो पूछा है. This will be mass into delta V. Delta P here, mass is not changing. So delta P is
Yes.
mass into delta V. Delta V is delta P divided by mass. I haven't solved the problem, but I've done everything required for you. All you have to do is substitute the values. Key catch here is area under the graph Ft will give me the change in momentum.
Yes, sir.
Change in momentum here plus change in momentum here plus change in momentum is net change in momentum, which I can equate it to mass into change in velocity. So it could be even change in mass into velocity in OR. Yes, that is the next question.
Yes,
Here
sir.
mass is not changing. Here mass is not changing.
Yes, sir. So if we just divide the force by mass, we will get acceleration, and then we can form three equations and solve.
That only.
Comfortably. That would be
Yes.
the regular way that students attempt this question.
Yes, sir.
Yes.
Generally, that is what they do. But I prefer this because slowly you people should start getting accustomed to this.
Okay.
So in that photo assignment, there were a lot of calculus problems also.
Yes, sir.
Yes, sir. 3, 4 were there.
हो गया कि नहीं?
सर डाउट
हो
तो हो
in the
गया
one
बट सर
question
खुद
was
से नहीं
missed.
हुआ था.
11th problem में sir ने
Yes,
11th
sir.
problem
हाँ
easy
सर,
था.
कुछ तो 2 बार इंटीग्रेट किया, so we
हाँ.
want to know
sir
this
उतना
solution
समझा
from
नहीं,
you
आप वो
also.
एक problem
वो
solve
Yes, sir.
वो एक बार से हो जाता है.
Yes.
इलेवेंथ क्वेश्चन कौन सा क्वेश्चन बता सकते हो आप?
फिर सेकंड पार्ट वाले.
accelerating systems वाले
Sir,
part.
should I send the picture on the group?
तो जिसमें चेन के लिए 12 दिया.
Yes,
Chain-
the log
उसमें
one.
I mean
mass,
एक
chain
एक
with
एक
mass.
सेट पे L+X है, एक दूसरे में L+C है, दूसरे में L-C है, वो वाला क्वेश्चन.
उस फोटो में दैट क्वेश्चन नंबर कितना था?
11.
11. सर लास्ट पेज
Accelerating
देखो, लास्ट
systems
पेज.
was the subtopic.
उस फोटो में क्वेश्चन अगर 11 है उसमें इंटीग्रेट क्यों करोगे आप?
Sir, you might be looking at the wrong 11.
Sir, yeah.
211 है.
अच्छा 2 है, एक सेकंड.
So we can just send the photo right now.
हाँ sir, on the group.
अच्छा, the question is a heavy uniform chain of length.
Yes, sir, that
Yes, sir.
Yes, sir.
Fixed pulley. Okay. Yeah, this is a dirty problem. That is agreed.
Yes, sir. Very dirty.
This came from IC4. Okay, now I understood. Is this over?
Yes, sir.
Now, in that next question, 14th question, F is equal to dP by dt is the complete truth. Yes or no? Till now, what you are doing is d by dt of m into v. This is m into dv by dt plus v into dm by dt. You were skipping the second part of it because you were dealing with particle dynamics. Mass
Yes,
was
sir.
constant.
Yes, sir.
Yes, sir.
In this problem, he tells you velocity is constant.
Opposite.
That's it.
Yes, sir.
dm by dt दिया हुआ है, force पूछ रहा है, velocity दिया हुआ है.
Yes, sir.
Yes, sir.
Done, sir.
Sir, in this, the force which is acting, it acts because of which external agent?
Rate of change of mass.
But which force is it? Like normal force or what?
This will create the force. This will be called a thrust force.
Oh, okay.
Hereafter called thrust force.
Done, sir.
So are we done for the day?
15. किसी ने नहीं पूछा है क्या?
नहीं सर,
नहीं सर
नहीं पूछा
No,
सर
sir,
किसी ने।
not at all.
Kinematic.
Okay. The 11th question थोड़ा लंबा पड़ेगा, जल्दी में कर रहा हूँ, देख लो आप लोग. Net acceleration will be the net unbalanced force. In general, if you have got two blocks on both sides, what is your acceleration? If two blocks on both sides, what is your acceleration? M2g minus M1g?
Yes, sir.
Yes,
M2g
sir.
minus M1g divided by the net mass M1 plus M2.
Yes.
We have
Yes.
done the same thing. Whole of this rope replaced with one single mass and place a rope of negligible mass. So यही तो आएगा,
Yes, sir.
right? So net unbalanced force आपको total weight this side, total weight this side लेना है. Right? How much are the weights given? F net unbalanced force is mass per unit length 12 into x. This is on one side. Into g minus mass per unit length into the other side is 12 minus x into g. Do you agree with this?
Yes.
It is as good as telling you make this string of negligible mass and place a mass of this value and this value here. Whole of the mass of the rope I placed it here. This is the net unbalanced force. First step, is it clear to all?
Yes, sir. Yes, sir.
Yes.
Agreed. So now will you get the acceleration? This divided by the mass. This if you add up mg by L into x minus L divided by m. Am I right?
Yes, sir.
Remove the mass. This will be the acceleration.
Yes, sir.
Yes.
And play it smart. Don't put it as dv by dt. I have x in the right. Put it as b dv by dx.
Yes,
G
sir.
by L x minus L.
Sir, now
Agreed?
integrate.
Yes, sir.
Now you know what to do next. Keep b. Take this to the right. Get an expression for v. V I will write as dx by dt. You get
Yes,
v
sir.
which you write
Yes,
as
sir.
dx by dt. Take dt to the right and integrate. ये integration शायद आपको आएगा ना यार. Do you know this integration?
Yes,
So
sir.
which one?
Root
Sir, which
over of
one?
dx upon
X square minus A square ना?
a square minus c square.
सर वो
सर
अपने
उसमें
कराया
वो
था क्लास में.
सब्स्टिट्यूशन
वो
करना होता है ना सर?
सर x को
is equal to a tan
tan theta.
थीटा लेके कर सकते हैं वो उससे
Bottom
बना.
line integration, if even if you are stuck up, I'm not worried about, because that integration will become peanuts for you once mathematics people cover that integration. But you
Yes,
should
sir.
know what we have done as far as the physics is concerned.
Yes, sir. So what will be the limits over here?
Limits
0
L
to
plus
x
c
normal.
to x.
L plus C to?
X.
Okay, sir.
So we can also write a as d2x by dt2 and then do, but that will be much longer.
Uh-huh.
Yes.
It becomes a second order derivation. Whenever I
Yes,
have
sir.
x in the right, left hand side, I'll make it preferably v dv by dx.
Okay, sir.
Complete the assignment 3. Next class I'll be starting friction. Last
Yes, sir.
half an hour I'll finish off the balance problems doubts.
Yes, sir. So can you give a hint for question 29?
Question
Yes, sir.
29.
Sir, and the last one also. The answer key, I think it is weird.
No, it is correct.
It
You
is
just
correct.
have to check that it is a vector.
It's correct.
Hey, 29 you want a hint.
Yes, sir.
After some time monkey stops moving with respect to the string. The change in magnitude of monkey's acceleration is. Hey, hint दूंगा तो वही solution बन जाएगा यार उसका.
Okay, sir.
Monkey stops moving with respect to the string means velocity of the monkey with respect to the string is 0. But with respect to ground, it need not be 0.
Okay, sir.
Chalo, see you people in the next class.
Bye, sir.
Thank you,
Bye,
sir.
sir. Thank you, sir.
Bye, sir. Thank you, sir.